Okay, so good morning again, everyone. Let's get started with our workshop, Applied Data Science with Pandas. This is going to be an introductory presentation about Pandas library. And as I said at the beginning, I'm sharing with you the content of this presentation through this link here that I shared already in the chat. So if you are just watching this after the presentation occurs, or if you, yes, I am recording the session already. Yes, so I'm recording this. If you want to access this presentation later on, I will share the link with the whole video of the presentation on our group. Anyways, you can also access all the files. Yes, I will share the link. Yes, I will share everything, the link of the video of this presentation, and also the files that I'm going to use in this presentation on our group. And yeah, let's get started. This is going to be an introductory content about Pandas, because of course we have a limit of time here to work in this presentation. And Pandas is a huge library with tons of features and functionalities, and wouldn't be possible to talk about every single thing that Pandas have to offer in just a short period of time as we have today. Okay, but let's move on. And I would like to start with what is Pandas and why you should use it for data science. So Pandas is one of the most used Python's library for data science and data analysis. It is fast, it is powerful, flexible, and easy to use. And on the top of that, open source tool for data analysis and manipulation. And of course, as I said, it is built on top of Python programming language. Some of the reasons for that Pandas has been widely used are, again, it is open source and its use is free of charge for everyone. It offers tons of functionalities. It's well supported by the community. So if you need any help while you're coding, you are stuck at some point, just Google the question that you have in mind, and for sure you will find someone who had the same problem, the same question, and for sure you will find a good response answer for your question, or you of course you will find where to ask your question to get some response for it. It's under active development. There are lots of documentation, tutorials, and question and answers available on the internet, as I said again. And it plays well with other Python packages. For example, Pandas is built on top of NumPy and works well with scikit-learn, which is another library for machine learning. I also encourage you to visit Pandas official website and check out some more highlights of Pandas under the About Us section. So you will have, you'll be able to access that under this link here. Moving forward, I made a really quick tutorial about Anaconda installation. I guess that all of you may have Anaconda installed already in your computer at this point, but if not, or if you have any question, if you would like to reinstall it by any chance, here's a quick guide on how to do it. I'm not going to go over all those steps because those are really simple, and the time that we have again for this presentation is short. So if you don't have it yet, you will have the chance to do it on your own later on. Also, I brought a really quick tutorial about how to use Jupyter Notebook. And again, I'm not going to go over all the steps here on how to run Jupyter Notebook, but if you have Anaconda installed on your computer, basically what you have to do is open the Anaconda Navigator and find the Jupyter Notebook icon here in your Anaconda navigator and click on launch. By doing that, you will see a new tab being opened on your default browser. And here it is, the Jupyter Notebook opened. What you will see here in this initial screen will be a file on your machine, a folder on your machine where you have all the folders and files here, and you will easily identify which is this folder by looking at your file explorer. And once you have the screen here, you can just click on new and then choose the Python distribution that you want to start your Jupyter Notebook from. And then you have your Jupyter Notebook ready to start doing some coding, okay? After doing that, you can save the file with whatever name you want, rename it here, and then it will be saved on your local computer, okay? I don't want to use that right now, so I'm just going to close this. So moving on, there are other ways also to run the Jupyter Notebook by not using the Anaconda navigator. You can also use the Anaconda prompt. So you navigate to the folder where you want to open the Jupyter Notebook. You may even create a new folder from the prompt if you want. I have provided a quick tutorial about that here as well. So just follow these steps and you will be fine. Moving on. By the way, this whole presentation I built on top of Jupyter Notebook. So everything that you see here, even though it doesn't look that we have any code here, if I just double click on those cells, we can see all the code, the markdown code, or even the HTML code that was used in each of those cells to display the information that we can see here. So every single thing that I built for this presentation, I built using the Jupyter Notebook. It's an awesome tool, not only for coding, but also to make presentations about the data analysis and data visualization that you have in mind. It looks really professional, and it is really to use it's really easy to use as soon as you have at least a basic knowledge on Markdown language or HTML, okay? So the first thing I would like to talk about Pandas is how to read files. If we're talking about analyzing data or do some data manipulation, we need to get this data from somewhere, right? There are basically two options when you are working with Pandas. You can create the data that you want to work with on your own. So you create two-dimensional arrays, for example, and then you transform that two-dimensional array into a Pandas data frame, for example. But this is not what we want at this point here. For the purpose of this presentation, we're going to work only reading data from files, okay? So the first thing that we need to do if we want to work with Pandas is importing the Pandas library. So let's issue this command here, import pandas as PD. And by issuing this command, if you are not really familiar with Jupyter Notebook, for example, whenever you type a command in a cell and you want to run that command, you can use the shortcut Shift plus Enter. And if you press those keys together, it will automatically run that cell that you have selected. Also, you can go to cell and run cells. It's going to run all the cells that you have selected. In this case, I have only one cell selected. After importing Pandas, it's important to know also that PD here is an alias for Pandas. It's used by convention. It's called PD by convention, but I could call this alias as any name as I wanted. This is just a variable that will be pointing to the Pandas library and allowing me to code more quickly without having to spell the full name of Pandas. Instead of that, I just type PD whenever I want to refer to Pandas, okay? If I want, let's try to read our first file, and I'm going to call PD, which refers to the Pandas library again, and we are going to use the read table function. Read table, and then I'm going to pass as an argument to this function the link where you can we can access the data set that we want to work with. And just to show you that this is an online source, right? So if I paste the link on my browser, I can see here the raw data where I am taking the data set from, right? Just give me one moment. Yeah, okay. So here we are reading data from an online source. And if I run this command, I see here like a summary of the data that I am importing. Because this data set has more than 4,000 rows, it's too much rows to show everything here at once in my screen. It would occupy the whole screen and much more. I would have to be scrolling all the way down to find the end of this data set. Whenever you have actually more than 60 rows in a data set, the Jupyter Notebook will show you only the first 5 rows and the last 5 rows of the whole data set. That's why we see this kind of visualization here, the columns 0 to 4, and then only the last 4 rows. Also, besides importing files from an online source, we can also import files from a local source. So I have the same file stored locally in my computer. And I have here the path to it. So data/chipotle.csv. So if I issue exactly the same command, the same function, but passing as an argument the path to a local file. Let's see what we have here. It's TSV, in fact, not CSV. So here we have exactly the same output that we had before, because of course we are reading the same file, but instead of reading from an online source, we are reading it from a local source. So let's take a look at how to save and properly visualize a data set after importing it, because in these cells, what we are doing here, we are importing a data set into a data frame. But we're not doing anything with it. We're just seeing the output that Jupyter Notebook produces after we issue this command. So to avoid having to type all of this command every time that we want to do something with this data, we can easily save this command into a variable. And that's what we are going to do here. We're going to create this variable called orders and save this command, create underscore table, and pass again the path to the file that I want to open, chipotle.tsv. If I didn't commit any mistake, if I run this, yes. I don't have any error, which is good, right? But I don't have any output. And why is that? Because Python is doing the operation here by reading the data set, and after that, the data set is being saved into this variable. And this saving operation doesn't produce any output. That's why we don't see anything here. But if you want to see a summary of the data after saving it into a variable, you can either call the variable name and run the command, and you are going to see exactly the same output as we are seeing here. Or you can call from the data frame that you imported, you can call the head method. And then you are going to see a summary of only the first 5 rows by default of this data frame. You can also customize how many rows you want to see. For example, 3 rows or, I don't know, 30, right? You can see, you can customize the number of rows that you see. As soon as the number that you pass here is no more than 60, if you put the number 60 here, you will still see the first 60 rows, but as soon as you try to put more than 60 rows in the head method here, you will see exactly the same visualization that we were seeing before, like this summary with the first 5 and the last 5, which up to the 60 that you are that you want to see here. Yeah, so let's go with the standard, the full visualization from the head. This is useful just to take a look if everything went well when you imported the data set or when you read the data set into Pandas data frame. It is possible also to read other file formats. And if we take a look again at the raw data that we are reading, this is a file called TSV, which is a tab separated values, which is a regular tabular data. And the character that is being separating the data in this data set is tabs. That's why it's called TSV. But we can, of course, we can read other types of data. Let's try this one here. I'm going just to copy this for short. The command here is really similar to the command we were doing before, pd, by calling the pandas library dot read table, and then I'm going to pass another data set URL here. This is an online source again, but this is a different data set. If we run this command, we can see this output that doesn't really look nice. It looks actually confusing, which is the data that we are looking at here. Looks like we have only one column and so many rows, right? We cannot really do much with this data as we see it right here. And the reason is because this is not a tab separated values file. The data in this raw file here is separated by the pipes, the pipe character, right? And the read table function, not this one. The read table function doesn't have this information by default. You have to explicitly say what is the separator that you want to use if the data set you are reading is different than a TSV file. So let's see how to do that. I'm going to copy exactly the same command as we did before. pd, we are calling the pandas library, and then read table, exactly the same function to read the file. We are passing the same URL, but after that, we are using this, we are setting this parameter called sep to the pipe character. And pay attention, we are setting the pipe character here inside of quotation marks, right? And because this is going to be read as a character, object type or data type, I think, yeah. And if I run this command, then I give the correct instructions to this function to read properly and properly separate the data into this data frame. But still we have some problem here, right? If we take a look at the very first row and also in the original row of the original data set that we're looking at, we see that we don't have the column names here, right? And this may be a problem because the first row is being taken and as the column names, and we cannot use it as part of the data set. But we can easily correct that by setting another parameter of this method. So again, here we are using exactly the same command, pd dot read table. We're passing the same URL. We're getting the same data here. We are setting the separator using the pipe, but also we can set this header parameter to none. By doing that, we are telling the function that this data set doesn't have a header, doesn't have the column names. So whatever you see as in the very first row of this data set is not the column names. So if we issue this command, what happens here is that the very first row is now being taken as part of the data set, not as the column names. But because we are saying that this data set doesn't have column names, what was set for the full column names were a set of integers, starting 1 and stepping on 1 for every column here. So it was automatically numbered from 1 to 4. Let's do one last step just to make this data more useful. We're going to give each column more meaningful names. And in order to do that, what we're going to do here is creating a list of all the column names that we want to use for this data set. So I am storing into this column names variable the list of all the column names. So the first column will be column user ID, the second one age, gender, occupation, and then zip code. If I run this command, okay, I have my list created, and then I can do my last step by calling again the function read table. I pass the URL, I set the separator, I set the header to none, but also after that, I set the names parameter to the column names. So I save the column names that I created before into this names parameter. If I run this cell, then I have a more useful data set that I can work with. All the columns are properly named with meaningful names. I can better understand what are those data that we see here. And then we can move on. Of course, we have seen so far only the read table. And you may ask, oh, okay, so according to the file that I'm going to read, I always have to set the separator. For example, what if I'm reading comma separated values file, right? A CSV file or any other type. I always have to pay attention. What's the separator? And I have to set it manually. Not really, because Pandas library has built-in functions to read different types of files. And also I provided here in the material the link to the documentation, to the Pandas documentation, where you can check out all the functions that are available so far in Pandas library to read files. You can read JSON files, you can read even Excel files. And as I was saying, you can read CSV files and so on. So you just have to take a look at the documentation and see if there is a built-in function to read the specific type of file that you want to read. If not, then you may have to set manually some specific parameters in order to properly read the file that you want. Okay. Moving on, I'm going to do something similar that we have been doing with the read table, but now calling this other function called read CSV. And as the name says, we are reading a comma separated values file, which is stored locally in my computer. We can see here by the path. If I run this command, I can see the summary of the data that I'm reading. I can also read, as I said, Excel files. And because there is a built-in function ready to make that work, I just call pd.read_excel, and then I pass the path to the file to read it. Again, it doesn't need to be only locally stored file. You can, if you have this data stored in an online source where you can access it directly through the URL, you just paste the URL here and you will have the same result. Okay, moving on. I mentioned in the previous topic a lot of times this name called data frames, right? I didn't mention series, but we're going to talk about both. Those are the most important Pandas objects that you should know about if you are going to work with Pandas. Again, to start, we have to import Pandas, and because I'm in this topic of the presentation, because I just have a new Jupyter notebook, every time that I open a new file, I always have to import Pandas to be able to work with the library, okay? So always the first step that I would do for every topic would be importing Pandas. And then what we're going to do here is reading another file. And this is going to be the same as the previous one, the Chipotle orders file. I am saving it into an orders variable. And let's take a look at the type of this object that we just created. So to get the type of an object in Python, you just type the function called type, and you pass as an argument inside of it the object that you want to check the type, right? If I issue this command, I can see in the output that the type of this variable or this object that I got from reading this data set is a data frame object. Although if I do this, for example, I am creating a variable here and I am storing into this variable one specific column from the data set that I read. And this column is the item name column, right? So I am extracting one column from the data frame, storing it into a variable, and then displaying it here so we can see only the values from the item name column. And if I check the type of it, I get this other data type here that is called series. So let's take a look at the differences between data types and series. Basically, in Pandas, a series object is similar to a one-dimensional array, but with the difference that a series has explicitly defined indexes. Although in a traditional array, you cannot change the indices of an array, right? But in a series, you can. You can set not only number indices, but you can set the indices as strings and any other thing that you can set as an index for the series. You may do that easily. A data frame, although, is a collection or is a list of series. You can understand it also as similarly to a two-dimensional array or a table with data arranged in columns and rows. Also, a data frame has explicit declaration for column names and row indices, as the series has. And a data frame is always composed by a list of series, as I said before. So whenever we see the output of a data frame, we'll see rows and columns, right? Always the columns will be in bold letters and the indices of the rows will be also in bold. That's why how we can differentiate those components from the data set by visualizing the output, right? And we have to keep in mind that every column in the data frame and also every row can be considered as series inside of this inside of the data frame. You can extract those pieces of data frame, and if you do, the result will be a series object. And whenever we see the output of a series, as we see it here, for example, the first part of the output of a series will represent the indices, and the second part will represent the values. There's no bold parts here representing columns and rows because there's no columns and rows in a series, okay? There's only indices and values. Moving on, we're going to maybe try to be more quick and see how to select one or more series in a data frame. We're going to start importing pandas as PD, again, to be always our first step. And here we are going to import a different data set. This is locally stored, we can see by the path. And this is data of appearances of UFOs. And let's see what we have here. We have different columns: city, colors reported, shape reported, state, and time. Let's see how to select one specific column by using brackets. We can see that I created this variable called df, just for short, to make it easier to call it whenever I want. It could be literally any name because this is just a variable. For short, I call it df, representing data frame. And I am saving this data that is a data frame into this variable called df. So from now on, every time that I refer to df, I am referring to the data frame that I am reading and creating at the beginning of the file. So if I call df square bracket city, look what we have here. We have the column city from the data frame. And again, if we check the type of it, we can see that this is a series object, right? Pay attention that whenever you are selecting a column from a data frame, you must pay attention to the spelling of the name of the column. For example, if I try to call the same column here, to invoke the same column by misspelling the first letter with lower c instead of uppercase C, and I run the command, I have this big error here saying that there's no such a column in this data frame, right? So pay attention to the spelling. You may have a lot of errors while selecting columns if you don't pay attention to that. There's another way to select a specific column from a data frame that is called using the dot notation, right? So here I can call the same column CT instead of using the square bracket and passing the value inside of quotation marks. I just simply call the data frame object dot and then the column name. It is much easier, right? Less things to type, less possibility of error, but you have to pay attention to some stuff here. You cannot use the dotted notation if the column name is composed by two words separated by a space, right? So you cannot invoke the column colors reported, in this case here, using the dot notation, colors reported. Even though I spell it perfectly correct, so I have all the capital letters placed, the space placed in the correct place here. If I try to call this, I will have an error, right? Because I have this space. Another situation where you cannot call a column from a data frame by using the dot notation is when the column name match any keyword of a property or a method available under the data frame object. So if you type your data frame object dot and then press tab, you will see all the properties and methods available inside of the data frame, the Pandas data frame object. And if a column of the data frame you are working with, if the column name matches with one of those keywords here, you would not be able to call that column name by using the dot notation. Okay, so pay attention to that. You may say that will be rare situations where you have this matching occurring. Yes, there should be like really rare situations where that would occur, but you would get an error that you don't really know what's going on. So keep in mind that possible problem. So I will leave the .ct here just to show that this is the series that we want to get from the data frame. Also, how to select 2 or more series at once. So this is really simple. You call the data frame object that you have, and then between the square brackets, you will pass a list of the names that you want to access. So because I am passing a list, I need the second square bracket here, the nested square bracket, passing all the columns that I want to select state. And here I have the output of the selection that I'm doing here. I am selecting 2 columns instead of 1. And why this look different than the previous output? Because I am combining here 2 columns or 2 series into only one object. And because a data frame is a list of series, when I join 2 series, I have as a result a data frame, not a series anymore. And I can prove that by wrapping this code here inside of a type function. So if I check the type of this object I'm creating here, I will see that the type of it is a data frame. And also we can see the differences in the visualization. The very first row, which is the column names, is in bold, and the first column here, which is the row indices, are in bold letter as well. Moving forward, we are going to see how to combine 2 or more series. Again, starting importing pandas SPD, and let's read our data set and create our data frame object. We're using the same data set as we were using before, the UFO data set. And let's say that in this case, I want to combine city and state into only one single column, defining the location where the UFO was reported, right? So how to do that? It looks difficult operation to do because you have so many columns, right? But it's actually really simple. I'm going to create a variable just to store this information, and this variable will be called location. And I'm going to store inside of it the selection that I want to do. So I am going to select the 2 columns that I want, city. And what I'm going to do here is concatenate the 2 columns that I want with a separator, with a character separating them. And just putting some spaces here to make it more readable. So what I'm doing here, again, I am calling the data frame, the column city from the data frame, and also the column state from the same data frame. And I am concatenating both with a comma and a space between them, right? And the result, when I run it and call the location variable, is going to be this. I have a series now, only one series, but combining the data from 2 different columns. And I can see here that the name of the cities are concatenated with the state, separated by a comma and a space right after that. Let me see. What we are going to do here, after creating creating this new series here by 2 combined columns, we saved this information into one variable, right? So what we're going to do here is assigning this new series to our original data frame. And how to do that? We call the original data frame, and we call a new column here called location. Pay attention that location is a column that doesn't exist in the original data frame. So by calling the data frame with a column name that doesn't exist in it, you are just creating a new column in the original data frame, and we are assigning the location series that we just created on the step before to this new column that we are creating right now. If we run the command, we don't have any error, which is good. And if I call the f.head, which means I'm going to call that summary of my original data frame, right? If I run this, I have this very last column here now called location, and the data inside of it is the data from this series that we just created. You see, the name of the city, comma, space, and the state. Now, I have another problem here because I just created one new column combining the data from 2 previous columns, right? I don't really want to see this information duplicated into several columns. So what I'm going to do here, I'm going to generate a new data frame by removing the city and state columns and leaving only the location column available for me. It will be easier to read this data set. So to do that, I'm going to call the data frame and pass a list of all the columns that I want to see, only the columns I want to see, including changing the order of the columns. I want to see first the location in the first place, and then the colors reported, the shape reported, and then the time. I don't want to see anymore the city column and the state column. And I'm saving all that again into a variable, and this is the original variable that I created and where I am storing the original data frame. So what's going to happen here after I run this command, I'm going to generate this visualization of the data frame, and I'm going to store it on the top of the variable that I have created before. And I'm going just to replace this new value in the previous value that I had inside of it. If I call the f.head, now I can see the new data set, the new data frame that is stored in it. The location is the first column as I specified. And then I have colors reported, shape reported, and time without having the city and the state separated as I had before. If we move forward, how to rename columns. We can import the data, the pandas as PD again, and then reading the CSV file. Now we are going to work with, the same file that we were working before. It's a comma separated values file. And let's see how to rename columns. Because I said, whenever you want to call the column name by using the dot notation, you cannot have a column name separated by spaces. So we want to correct that. Let's check out how to do this. First, we can call these df.columns, which shows us all the column names that we have into our data frame object. We can also call df.index to see all the indexes of our rows. And the indexes are numbered, and starting from 0, it stops on 18,241, and the step is 1, so it increases every time by 1, right? So columns and index are properties of the data frame object. that are available for us whenever we want to work with it, either changing those properties or just accessing the values that they have inside. Let's see how to rename the columns then using the rename method. We can call the df, our data frame, of course, dot rename. And inside of this rename method, we are going to pass columns equals, and we are going to assign to this columns argument here a dictionary of all the columns that we want to rename. So in this dictionary, dictionary is composed by a key and a value, right? Separated by column. So in the key of the dictionary, we pass the original column name that we want to rename, and the value of it is going to be the new column name that we want it to be renamed. So we are going to touch only the colors reported and the shape reported columns, and we want to replace those names by colors underscore reported and shape underscore reported. If we run this command, we have this result here. You see colors reported with the underscore separating them, and shape reported with the underscore as well, as we said before. And if we issue the dataframe.columns command, we can see in this case, because we didn't save this information into any variable, we can see that the df columns doesn't show the result that we got before. It's still the name of the columns is still separated by spaces. And I also didn't set the in place equals true, which is a parameter of this method that should be set to true if you want to save whatever is the change that you are doing to the data frame. So even though I issued this command before, because I didn't set the in place to true, the information was not saved. But now the change was not saved. But now if I run this command with the in place set to true and run again the df.columns, I will see that the property columns of the data frame was changed to the values that I've set before. I also can do the same thing, renaming the column names more easily by just saving a list of the column names into the columns property of the data frame. So what I'm doing here, I'm just creating a list of all the column names that I want to replace the original column names. And then I call df columns equals the new list of columns that I just created, right? So I'm going to rewrite the columns property of the data frame. Let's run this command, and if I run the dataframe.columns property, we can see that now all the names are lowercase, as I've set before. So they match exactly with the list that we did here above. We can also rename columns by using string manipulation. So I'm going to read again the original data set, because we have changed so many things in the original data set. I want just to get it fresh from start. So that's why I'm just reading it again here. And by using string manipulation, I would like to do exactly the same thing that we did here by replacing the spaces with underscores, because imagine if you have a data set with, I don't know, dozens of columns, right? It would be harder to do this, this kind of renaming. So you can more easily do this by using string manipulation. So I am creating a new variable here called df new calls, and inside of it, what I'm going to do, I am calling the data frame, the columns property of it, and the columns property, I'm calling this string.replace function here. And from the string.replace, I pass two values as arguments. The first value will be what is the character that I want to change. The second one will be the character that is going to replace the previous one. I just save this into a variable, and then I just assign this new variable to the columns property of the data frame. And here it is. The new columns names now with all the spaces replaced or changed to underscores. We can also book changing the case of the column names. For example, I'm calling the columns property of the data frame, and I'm calling this str.lower. And by doing that, I'm changing all the columns names to lowercase. And they were, as we see, they were uppercase before, now they are lowercase. We're going to see more detail the string handling. Now let's take a look at how to remove columns and rows from a data frame. Again, we're going to import the pandas spd. We're going to read the file into our data frame. This is the same data set that we were working before. And let's see how to remove one or more columns. To remove a column, you can call the data frame name dot drop method, right? And inside of the drop method, you have to specify what is the column name that you want to delete. So colors reported in this case, and you must specify the axis, because originally the drop method has the axis set the full value set to 0. That's why if you want to use it to delete a column, you have to specify that the axis you are working with now is the axis number 1. The only two possible values for the axis will be 0 or 1, because a data frame has only 2 dimensions. It is, as I said in the beginning, it is similar to a 2-dimensional array. So you're working with a column, the axis has to be set to 1. I'm going to also set the in place equals to true to save this modification I'm doing in my data frame. And if I call the df.head, I see here that the colors reported is not here anymore, is not part of my data frame anymore. And again, because I set the in place to true, I cannot retrieve this column anymore unless I read again the original file. Let's see how to drop 2 or more columns at once. So you use the same method, but instead of passing only one column name, you have to pass a list of the column names that you want to delete. Pay attention that the list of the column names, because it is a list, it has to be wrapped inside of square brackets. And then you set again the axis in place to true to save the modification. And then if you call the f.head, and then we have here our new data frame now without the columns city and state. What if you want to remove 1 or more rows? So as I said, you can use also the drop, but instead of passing the name of the columns, you pass the index of the rows. In this case, the indices of the rows are numbers, right? So we are passing, for example, let's delete the first column, which has the index 0, right? And setting the in place to true. In this case, we don't need to set the axis, because I said the axis is set to 0 as default. Let's run this and call the f.head. And we have here the data frame now without the first row. We can also delete a list of rows by passing a list of indices, right? So we are going to delete here now the rows numbers 1, 2, and 3. I'm setting the axis to 0 just to show that we can do it explicitly if we want, but this is not really necessary as I didn't set the axis to 0 here above. If I run this command, I will see the new data frame generated now without the columns, the rows 1, 2, and 3. Moving forward, sorting. Sorting is another really useful thing to do when dealing with data sets. And we're going to quickly see how to do sorting with data frames in series. Here we are changing the example, the data set that we're taking. What we are seeing here is a list of IMDb ratings, right? So this is a list of movies and the rating of them. We have the titles, the content, genre, duration, and actors list. Let's see how to sort series, for example. Why sorting a series? We are calling here the data frame, df. Again, df is the variable name where I am storing my original data frame, right? So df.title, I'm getting the title column only the title column. And by calling the title column, I am calling this sort values method. If I run it, I have the output as a series. And the series is sorted in ascending order by all the values that we have here. We can also use do the same thing, but using the square bracket, because this is another way to call a column from a data frame. So the same thing can be done by calling a column by square bracket. And also, if you want to sort in descending order, for example, you can call the same thing, the column name that you want to sort, and then the sort values method, the same method that we were using before, but you can pass a value to ascending parameter of this method here to false, because the ascending parameter is set automatically or by default to true. So if you change it to false, you are going to sort the series in descending order. You can also, based on a sorting of a series that you have done before, you can do that. You can sort a data frame based on a series. So let's see how to do that. You call the data frame object, and from it, you call the sort values. Look at the difference here. The sorting that we were doing before, we are calling first the column, and from the column, we are calling the sort values method. But here we are calling directly the data frame object, and from it, we are calling the sort values. Both objects, either data frame and series, both have the same method available, which is called sort values. But if you want to use the sort values from a data frame, you have to pass inside of it as an argument the title, the name of the column that you want to make your sort from the data frame. And here it is the result. These, the output from it would be, of course, a data frame, not a series, because we are calling the sort from a data frame, not from a series. You can also use the you can also sort by in descending order by setting the ascending to false. This is exactly the same as we did by sorting the series, but now we are sorting a data frame. We're calling the name of the column we want to sort and setting ascending to false. This is going to result in a data frame sorted by title, in descending order. We can update a data frame based on sorted values, right? Because whatever we are doing here before, we're not saving this information anywhere, either on a variable or we're not changing the original data frame. If we call the df.head function here, we can see that the original data frame is preserved, is not changed, right? The order of it was not changed, although we issued those commands here. And the reason is we didn't use the in place parameter inside of the method here. So if we call the same command to sort it and pass the parameter in place, we're going to see that now we have changed the original data set. And from now on, whenever we want to call this, we want to visualize this data frame or to do any operation with it, we must know that it is sorted by title from now on. We can also do some sorting by any other column. Let's now sort by genre, for example. And the same thing is done. But in this case, just pay attention, I didn't use the in place to true. I didn't set in place to true. So if we, oh yeah, in this case, this is another method of updating the data frame, of course. In this case, I didn't set the in place to true, but on the other hand, I am saving this result into my df variable, which is representing the data frame. And because I am saving this into a variable, whenever I call back the head from this variable, the head method from this variable, now I have the result updated to the output that I had here before. And also we can sort, of course, based on multiple columns, not only one. So we can sort by star rating and genre, for example. And whenever we are calling more than one column, again, we have to pass it as a list to the method. And I'm setting ascending to false because I want to see the most high star rating before. So we have here the list sorted by star rating and then by genre. We can also filter by rows. So again, we're going to import pandas SPD. We're going to read the same data set that we were working before. And let's see how many different genres are in this data set. So what I'm doing here, I'm calling the genre value, the genre column, and I am calling this method called value counts. And the value counts will give me the number of times that each individual, each unique genre appears on my original data frame. And I have here that I have 278 occurrences of trauma, 156 occurrences of comedy, and so on. That's what the value counts method does here in this context. Let's filter by action and see two different outputs from the filtering. So let's see. What we're doing, we're calling the genre column here, and we want to see the output of all the values that are equals to action under the genre column. And the result of it is a series object with true and false values set to each row. Again, this is just giving us the result of this comparison, right? In programming language, whenever you do a comparison, it always returns true or false, which means if the comparison matches or doesn't match whatever you are comparing, to another value. But I can call my original data frame, and inside of it, I want to see only the rows where I have these matching happening, which means I am filtering the rows of my data frame only where the genher, the value under genher column is equals to action. So if I run this command, I have data frame output, but only with the rows where I have this matching occurring here. Let's, if we take a look at the genher column, we'll see only action values inside of here. You can also make a filter using multiple criteria. And let's see. In this case, I want to see, again, all the action movies, and pay attention to the ampersand sign that we have here. I want to see another filter being applied here by all the star ratings that are greater than 8.0. So both filters should be active in the view that I am generating, and here it is. All the values, all the rows that I have displayed here are matching both conditions. The star rating are always greater than 8.0, and the values under genher column are equals to action. So moving on to string handling, and I am almost finishing. I know I am going over the time that was set before, but I promise I am almost at the end of the presentation, okay? So string handling and changing data types in series. We're going to import, again, Pandas, SPD, and we're going to read our data set into the data frame, and here's the summary of the data we read. We're going to change all the value types to uppercase, for example. So to do that, we call the data frame, the column that we want to change the values. And remember the str dot lower that we used before, the str dot, I don't remember what was the other one that I used for string handling. But in this case, we're going to use, from the column name, we're going to use str.upper, which is going to transform all the values from this column to uppercase. We can do something similar, but calling str.lower, and what's going to happen is all the values from the column item name is going to be changed to lowercase. There is also so many other functions available from this str property, and one of them is title. In this case, whenever we call it, it transforms the value inside of this column, the values inside of this column, changing to uppercase only the first letter of each word. This is really handy whenever you have a big set of data and the data is not normalized. It makes it easier to read it and to analyze it if you have like a pattern of case for the values. So getting the series result from the operation. So what we're doing here, we're calling one specific column, which is called item name. And from it, we want to get only the values that contains the word veggie. And this is a similar result as I showed before when I made a comparison, right? All the values under genre of the movies, right, that were equal to action. In this case here, I want to see all the rows that under item name column contains the word veggie. That's why I have, again, a set of results of true and false. And how do I use that? This is not really useful, right? We cannot analyze any data from these directly, but we can use these to make a good analysis or filter of our data. So to do that, we call exactly the same command, but we pass it inside of the square bracket by calling the data frame. So the data frame square bracket, and inside of it, we make this filter. And by passing this filter inside of the square bracket of the data frame, we have here all the rows where under item name column, we have the word veggie, as we see in the result. We can also replace characters by using this string handling method. And this was the method that I was trying to remember before, the replace method. We have used it before in a previous example. Let's issue the F types so far. Okay, so this is a practical example where you would want to replace characters into a data frame. For example, if we take a look at the data types from the item price, which is the last column of this data frame here, the data type of it is object, which means it's being read as a string, not as a number, not as an integer or a float. So we cannot perform any calculation with those values here. So we want to change the data type of this object here. And before changing the data type, before to do that, we need to remove this $sign from it. So that's what we are going to do by issuing this command here. We're going to replace, so we call the column name and str.replace. So we're going to replace the $sign by an empty string. And the result of it will be this. The last column will have only the numbers, not anymore the $sign. After doing that, yeah, I'm just saving this this command into a variable name because I want to replace that into my data frame, right? So this is the same operation. I want just to see the result of it by calling the variable name. So I have the result without the $signs. And now I will take exactly that series that I just generated here above, and I call its name, and I call the method called sType. And inside of it, I pass as an argument what is the data type that I want to change it to. So, and at the same time, after I do this change, I am replacing the output from it inside of the same variable that I created. So if I call this variable name right after and run it, now I see that the data type of this series now is float 64, not anymore object. So it means it was transformed from object to float 64, and now I can just replace the values from the item price on the original data frame with the new column price that I just generated here that has a float data type in it. And here I'm calling the data types of the new data frame, and I see that the last column item price now has a float 64 data type. And for the last, I promise this is the last part of the presentation. We're going to see how to do basic analysis with group by, mean, min, max, and plot. And again, we're going to import pandas. We're going to read a data set that we want to work with. And this is a data set about alcohol consumptions around the world. So we have the countries, the different types of alcohol drinks, and the amount of servings per country and per continent. So let's see how to do some things here. Let's start with the mean of the beer servings column. So what we're doing here, we're calling the data frame object, and from the beer servings column, which is this one here, we're getting the mean, right? And because the data type of the beer servings is a number, we can easily call the mean method here to get a number as an output, right? But also we can use the group by here to see all the means calculations, but grouped by continent. And to do that, we call, again, the data frame, and right after it, we call the group by method with the column name that we want to make the group by work. So because we want to make the group by continent, we pass the continent column name here, and right after that, we place what are the values that we want to show in these groups. The values will be the mean of beer servings, right? And this is the result. We have a series result, a series object as a result, and we have here the mean of beer servings by continent. We can apply the same logic to retrieve the mean of the same column from one specific continent. Let's see how to do that. We call one specific continent, let's say North America. So the f.continent, which is the column that we want to see, equals to North America dot beer servings dot mean, right? So we are wrapping all that into the df, into the data frame by using the square bracket, and then we have one single value that specifies what is the mean of the beer servings under this continent. We can also get min and max values, whatever we have number values in our data set. So here we are making a group by, but instead of getting the mean, we are getting the max values by continent. So the max values by continent that we have in our data set would be this: 376 for Africa, 247 for Asia, and so on. And the same thing we can get, or a similar thing we can get, if instead of using max, we use mean. So in this case, we'll have the minimum values per continent. We can do some, we can aggregate series calculations, for example, into a new data frame, because so far we're doing group by, we're doing min and max, but only getting series as an output, right? What if we want to see the whole data frame, or a totally new data frame based on the groupings that we are doing here? So here we are doing the same grouping, or a similar grouping, group by continent, beer servings, but now we want to aggregate. We want to aggregate all the calculations that we have been done before, the mean and max, all into one data frame and display it. So if we run it and call summary.head, or let's call just summary. This is the output that was generated from here. Look at this. We have in each column the results of each of those operations that we did. So we are aggregating all those calculations and grouping them by continent. And from this, we can also do a simple plot. And look at this. Really nice, good looking result that is easier to read and to understand, to analyze, better than a simple table as we had before. So in a graphical representation, it's easier to see those values, right? So to have a plot like this, you just call the data frame that you have dot plot. And that's it, as simple as that. I just set a parameter here to bar, because if I don't set anything, the default value of the plot would be as line, right? But I don't think this kind of graph is really interesting to see in this way. So what I do, I just set a different kind of plot. I just set it to bar to see in a more data in a more interesting way. I can also get the mean directly from the data frame. Yeah, so I have by calling the group by and the mean from the group by using the continent as a group by here, I will have the mean of all the values that we have in our data frame, all the number values here, but grouped by continent. And we can save the output into a variable, which is not something really new. So in this case, we're going to make the same grouping that we did before and saving it into this mean by continent. If you call this variable here, we're going to have the same result. And what if we want to plot this result, exactly this same result? Instead of writing df.groupby.continent.mean, because I saved all of these into this mean by continent variable, I call my variable name dot plot, and then I set whatever are the parameters that I want to set. Let's say that this line graph is not really interesting to see, or it's kind of confusing for this type of data. So we can set the kind of it to bar, as we said before. And we have now more interesting data. But also it looks too small, maybe we have too much data for such a small graph. So we can set this, the size of the data we want to see. So fig size equals, and these values are in inches, if I remember well. And the first value is the width. The second value is the height. And you have to pass those values as a tuple. As you see here, I'm passing them wrapped into parentheses. So if I run this, I have a problem here. Of course, I have a typo in my fig size. Yeah, now it looks bigger. It's easier to read. This legend is not over my graph, but I can also set a title for it. So I can set the title as, just copy this for short, the amount of alcohol servings per type by continent. And I have this nice small graph here with the data frame that we just generated. We can see that the column names are color typed, color coded here on the top, so we can see the legend of each color, and it is really nice and easy to read. Also, another thing you can, just to omit this line of output here, you can, whenever you plot something on Pandas, you place a semicolon at the very end of the command here, and by doing that, you are going to omit that first line of output here. And yeah, by showing that, that was the end of the presentation that I wanted to make. I know I used like a longer time that I was expecting before. but I think it was necessary to spend more time at the beginning, better explaining the base concepts. What we have at the very end here are some exercises. You can do that on your own. As I said at the beginning, I'm going to paste again the link where you can have all of the files that I used in this presentation. I pasted that link on the chat of this call right now. So take this link, take all the files that I used here. You'll be able to run all these commands, modify it as you wish, as you want, play with the data, and also try to do the exercises on your own if you want. And also, if you want to compare your results or the commands that you used to solve the exercises, you will see the very last topic that I have in this table of contents here, the very last file. You will see all the answers for the questions that I provided here for you. I think that's all for today. I would like to thank you all for being here, for your patience and attending this workshop. I think it was a really good experience for me, and I wish you all enjoyed it as well. If you have any question, also I'm available to clarify any questions right now if you wish to ask something, or if not, you have my my contact into this presentation. I have provided my email address here, my LinkedIn account as well. So if you want to get in touch later on, feel free. And I think that's it. Thank you very much.